All right, so we're going to focus on converting from log form. These are really the only two big things you need to know, which you should have already gotten from the intro videos, and exponential form. So obviously, all we're really doing is rearranging the letters a little bit and converting from one form to the other. So this problem is in y equals b to the x form. So we want to convert it to log base b, y equals x. So you'll notice the 125 is in the y slot. So when I rewrite this, it's going to be log 125. You'll notice the 5 is the base, the big number. So the 5 is going to be inserted right here in log form. And then finally, the x is the exponent. So that 3 is going to go in for x here. We're just converting it from one form to another. When you have real numbers, there's an easy way to check this. If you go and press the math button, and you can scroll down here and find a button that says log base, and we can type in log base 5 125, and it should evaluate to 3, and it does. Of course, this only works when you have real numbers and no variables. Same thing, question 2. That's an exponential. I'll leave that one for you to convert to log form. Same exact idea. You got a fraction there, but same idea. Let's do this one, but really same idea. This is an exponential form. We just want to rearrange it so it's in log form. So the n goes in for y. So I'm going to rewrite this. Log n equals, the base is 3. So 3 is going to go in for the subscript in the logarithm. And then the only thing we have left is the variable m. Pretty straightforward here. And here we're going the opposite way. They give it the problem to us in log form. We want to convert it to exponential. So on the right-hand side of the equal sign is 3 and x. So that 3 is going to be our exponent. I'll go ahead and put it up there. The y is 1/64th. So it's going to go in for the y variable right there. And the only other number left is our base, which is 1/4. And again, when you have real numbers, this can easily be checked. If we type in 1/4 and raise it to the third power, we get a decimal. But if we convert that decimal by pressing the math button and then number 1 for fraction, we convert it back to a fraction, we see it as 1/64th. All right, so here we're substituting 243 in for x because we're finding f of 243. So essentially we want to solve the problem y equals log base 3 243. If we convert this to exponential form, so this is log form, I want to convert this to exponential form, which would be 3 raised to the some power equals 243. Well, here's where it's helpful to know your powers of, and of course, if you don't, you can always use your calculator to kind of refresh your memory. 3 to the third is 27, 3 to the fourth is 81, 3 to the fifth is 243. So this tells me I'm going to rewrite this problem as 3 to the raised to the y power equals 3 to the fifth power. So that means since both sides of this equation have equal bases, the bases are the same. So that means the exponents have to be the same. And y equals 5. All right, this next problem can be solved in a similar fashion. We are trying to find f of radical 27. So basically, we are trying to solve this function when x is radical 27. So again, this is log form. Let's convert this to exponential, which would be 3 raised to the y power equals radical 27. You got to use your knowledge of radicals here to solve this one. It's going to be 3 raised to the y power. 27, the square root of 27 is the same thing as 27 raised to the 1/2 power. 27 you should recognize as a power of 3. It is 3 to the third power. So I rewrite 27 as 3 to the third. But remember, this is not just 27. This is 27 raised to the 1/2 power. So we have the same base, but basically we need to simplify this a little bit further using our exponent rules. When you raise a power to a power, you multiply. 3 times 1/2 is 3/2. So now the base is the same. So y equals 3 over 2. And remember, calculator can be your friend to check your answers more than anything. If we press math, go and find log base, and we type in the original problem, log base 3, radical 27. Got to show work, but this is a good way to check our answer. We get 1.5, which is of course equivalent to 3/2. And let's try this final problem, question 12. So I'm going to rewrite it, log base 6 instead of log base 6x. I'm taking this and substituting it for x. So I want to convert this to exponential form, which would be 6 raised to the y power equals 6 times the cube root of 6. The 6 times the cube root of 6 is the same thing as 6 times 6 raised to the 1/3 power. When we multiply two like bases, then we add the exponents. So this is 6 to the y power. 1 plus 1/3 is 4/3. And we already have the same base of 6. So y equals 4/3.